Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib. I'm here with JP. How are you, sir?
I'm doing really well, thank you.
And today's wonderful guest that we are excited to speak with is Dr. Rollin McCraty. This episode of the Health Upgrade Podcast is brought to you by Truvaga. Have you been looking for a simple way to feel calmer, think clearer, and sleep better? Imagine achieving this with just 2 minutes a day. I'm excited to introduce you to Truvaga, a handheld device that supports your nervous system through gentle vagus nerve stimulation. As a doctor specializing in functional health and wellness, I've seen firsthand how Truvaga has accelerated healing in my clients. I've used this device to help people with a range of issues, from sleep disturbances and heart palpitations to digestive dysfunction, nervous system imbalances, and mental wellness concerns. The results have honestly been remarkable. Truvaga is designed to catalyze and accelerate the shift in your body from fight or flight to rest, digest, and recover mode, helping you manage stress, maintain mental clarity, and unwind more easily. It's not just theory. I've witnessed its positive impact on real people facing real health challenges. The best part? Truvaga fits seamlessly into your routine. No need to carve out hours for wellness. Just 2 minutes a day can make a difference. It's a small investment of time for potentially significant benefits in how you feel and function each day. If you're curious to experience Truvaga for yourself, visit truvaga.com/upgrade. You can save $30 on your device by using the code UPGRADE30 at checkout. Remember, that's truvaga.com, truvaga.com/upgrade. It might just be the first step towards a calmer, clearer you, just as it has been for many of my clients. How are you, sir?
I'm doing great. And thanks for the invitation to be on your podcast. And nice to meet both of you.
Yeah, we're absolutely excited to have you on and to get into this topic that you have kind of dedicated your entire life to, which is coherence, heart coherence, and understanding, kind of just going beyond what is known in terms of HRV, heart rate variability, into the frequency of life and how life is connected and the connectedness of the world. And so I'm really excited to dig into this with you. Why don't we start off just getting to know you, your journey? How did you go into or become interested in this particular area of study?
Oh boy, kind of a long, windy story, but I don't want to take too much time get into this. But I started, my professional career as a communication engineer. I used to work for Motorola, and that was fun, but that wasn't my path. I was more of a serial entrepreneur type at heart. And so anyway, let me probably tell a bit more of that story. I was always kind of curious. I think I just kind of came in as a curious kid, right? A sense of adventure, but it was always wanting to, I was always asking professors and the things a little bit, well, what is a magnetic field or a gravitational field? And they would give me here's the formula that explain it. No, I got that. What is it? That describes how it behaves, right? No, what is it? Now go away. Don't ask that. But they weren't quite that. It was pretty much like that, and which drove me a little crazy. So I ended up, I was in Nebraska at this time. I've actually found a book in a bookshop at the University of Nebraska where I was doing a lot of work for Motorola at that time. Anyway, it kind of led me to my first introduction to consciousness and the idea of consciousness and some of the concepts within that world, which led me to move to California and get a degree in consciousness studies. This was in the late 70s. And I won't go into all that, but that sort of changed directions for me. So learned about meditation and biofeedback and a lot of these different things that existed at that time. And then it got involved in introducing spirulina to the world through some of that, with the first company to actually bring this green algae stuff to the Western world. And And the motive really behind that was a humanitarian motive. It was this food that you could live on, and a few people lived on it for a couple of years just to prove it, that were part of that group and stuff. And anyway, in the early 80s, the National Enquirer, I don't know if you have that up in Canada or not, but it amazed me the power of that supermarket rag magazine, because they did a front page article on spirulina. And in the next 3 weeks in the division that I was running of that company, we went from $150,000 a month in sales, which wasn't bad, right? From, a startup to, I wrote personally about $20 million of business in 3 weeks. After that, I mean, it was like, that's a whole other sub-story, but how we pulled that off. But anyway, we took the profits of that and went to the deserts of Southern California to prove you could go grow spirulina and feed the world's hungry population. And actually did that, kind of way, in hindsight, way ahead of our time. These are all solar-powered spray dryers and big fields and all that. Anyway, that went absolutely nowhere in terms of feeding people. And so meanwhile, I've got a degree in consciousness studies. I know that it's about consciousness. Well, no, I didn't. And so in hindsight, I look back on that period, and it's kind of when my idealism bubble got popped. Because the reason that it didn't go anywhere was a lack of the conscious awareness of, it wasn't technology, it was all the bureaucracy and the political stuff that just. So I basically said, then heck with this humanitarian stuff. I'm going to go make money again, and started a company in electrostatics, actually. Invented some new technologies, and, went from a garage startup to a pretty successful company pretty quickly. And that was a good time. Don't get me wrong. That was a riot, but a few years into that, there was this kind of deeper, I would say in my own heart, of kind of I won't say emptiness, but a prompt that another sports car in the driveway wasn't going to quite do it. There was a deeper fulfillment I was looking. So I met Doc Childrey through some mutual friends, who's the founder of HeartMath. And he was on the East Coast at that time, and I had to be back there doing some business. I'll go meet this character that I'm hearing about that I should meet, and, spend an hour or two with him. And, well, ended up spending 3 days. So that was really the genesis of really my introduction to the deeper aspects of the heart and what it's really about. And so I brought some of what I learned from him and the ideas and my own kind of, I would say, more deeper heart awakening that occurred during that period to my company. And can honestly say I made more personal progress in my own growth and consciousness in multiple domains, right, in 3 or 4 months than I had in many years of meditation practices. So I went, okay, followed my heart and sold that company and helped move to back up to actually to where I'd gone. Originally, I landed in California, on the Santa Cruz area, Santa Cruz Mountains, and helped Doc and a group of others found HeartMath. And so given my background, I started the research side, and then I had to go learn about psychophysiology, and so ended up getting a degree in psychophysiology. And so that's 30-some years ago. Anyway, I hope that wasn't too long of a story. But,
No, it was great. I love to hear kind of the journey, because there's always steps along that path that lead you to where you currently stand and to the expertise that you then hold. And it sounds very much like that consciousness piece was one of those first steps in identifying that internal question of what are things, what are we, how are we connected to the differences or the different things around us. And I was watching a presentation that you gave a little while ago, and it talked about a study that happened in the 1920s where human events followed solar flares or solar winds, and that studied the alignment of solar winds and human events literally were rhythmic in their patterns over many decades. Was that one of the Yes. Was that one of the first introductions to your?
No, I was much later, actually.
Okay.
Much later. And if you want that journey, I can kind of maybe give you kind of milestones along the way.
Sure. Yeah. Whatever milestone fits next in that HeartMath journey. Yeah.
Yeah. So we started really our lab here, the HeartMath Research Center, and really 1992 is when we kind of started. And, so I have a communication engineering background, but I knew nothing about electrocardiograms and things like that. So that was a learning curve there. But we started primarily as a psychophysiology lab, and I have to keep in mind, this is early 90s. So this is long before positive psychology movement and these kind of things. I mean, years. And a lot of people probably don't remember that far back, but we didn't have internet back then. You actually had to go to the library to get research papers, get journals off the shelf and photocopy them and all this kind of stuff. So spent a lot of time.
My parents had bought an encyclopedia that I had used for a lot of my research when I was much younger. Yes. So.
Right. So it was a lot of trips to, I'm kind of situated right between Stanford and UCSC, University of Santa Cruz. So a lot of trips to the science libraries back then. But anyway, there was maybe 3 papers I could find at that point where somebody had actually done research around the physiology of positive emotions. Thousands on stress, depression, anxiety, but very little people had looked at, well, what really happens in our bodies, when you're feeling something like appreciation or compassion or kindness. Very, very little. So we kind of given on my own experience, right, kind of leading up to all this, right, with the heart and appreciation, these kind of exercises, we started looking at and learning about all these 3-letter acronym things, ECGs and EEGs and EMGs and the list, right? And we tried everything back then, and it was actually a lot of fun, very experimental. And at that point, I really didn't have any kind of formal education in psychophysiology, so we tried stuff that shouldn't work had I been academically taught, but did work in a lot of cases. Anyway, let me make a longer story short. What we ended up kind of discovering in a way was that of all the stuff we were measuring, that it was the rhythms of the heart that was most reflective of emotional state to begin with, and that different emotions had led to different patterns. And this was kind of where we got onto what's now called heart rate variability. And nobody had ever heard of it at that time. And that, I'm going to kind of shortcut some of this too, but not only that different emotions had different patterns, but when we felt something good, like appreciation or these positive emotions, it wasn't just a different pattern. The physiology was literally shifting into a different functional mode, which years later we ended up naming incoherent and coherent heart coherence. And that a lot of rabbits got chased down the hole to understand that in the years after that. But that work drew, I have to always give credit to a lot of awesome mentors. So I learned a lot from some really neat people like Joe Camilla, the father of biofeedback, was, loaned us his EEG equipment. And Carl Prebrum ended up spending a lot of time here. I don't know if you know that name or not, but pretty famous guy, considered by most to be the father of modern cognitive neuroscience, and holographic perception theory. All that was Dr. Prebrum's work. And it took me a while to understand why he was so attracted to what we had found, but he finally, we actually became really good friends. And then much later, well, anyway, so we were doing the heart-brain stuff, and then I got introduced to neurocardiology through some friends and became very good friends with Dr. John Armour. He's another Canadian guy. I don't true to his friends, he's retired now. So I learned a tremendous amount from him and spent time in his lab, actually getting in where they were putting electrodes and beating hearts, right, in the neural system and hearts and the nervous system of hearts and this kind of thing. And anyway, it's kind of a next jump then was we were also doing work with, actually back then, DNA to see if you could intentionally connect with DNA and cause measurable changes in DNA. So again, this is the early 90s. And you could, and that was interesting, but didn't publish a lot of that back then just because I didn't want to be known for that kind of, it was more curiosity. But anyway, so that led to, this is where my previous engineering work really came in handy, because when you put electrodes on the body, of course, you're measuring current flow. That's all they're really measuring, right? But whenever you have a flow of current, you create a magnetic field. Right. So this was my old career. In hindsight, it was all just right? Because so you need a different device to measure that, called a magnetometer, of course, which you guys are probably familiar with. Most larger hospitals have what are called MCGs, right? Magnetocardiogram, or you never touch the body. But that wasn't so much true then. Those actually came a bit later with the development of squid-based magnetometers and things. But So anyway, we were measuring other ways of measuring the magnetic field and showing that it would actually, you could measure it external to the body. And that was not unique. I actually have a book on my shelf behind me here on bioelectromagnetism that blows. Actually, it's amazing what came before us. There's a graph in this book, and that was done in 1886, where they accurately measured the magnetic field of the heart, had the shape of the field right. I mean, external to the body. But then what we then did was using the same kind of techniques I used to use in my Motorola days to decode or, look at the information being demodulated, look at the modulated energy being carried by the heart's field. And we're able to show that actually has a direct mathematical relationship back to the heart rhythm, so that that kind of then led to the understanding we are literally broadcasting, radiating our emotional states into the field around us. And then next step in that was to say, okay, well, that's cool, but so what, right? And well, it's kind of almost embarrassing to tell the real story, but I'll tell you. So we were saying, okay, so we were doing these water experiments. One of those mentors in that area was William Tiller. He's a head of material science at Stanford, and he was a world expert in crystallization and this kind of stuff and water he was interested in. So we were doing a lot of water experiments and crystallization experiments and things too. So we had this idea. We stuck an electrode in a glass of water to say, okay, well, can I measure my heartbeat in this glass of water sitting in front of me? And we could. That's pretty cool. There was all sub-stories here that I'm not going to get into, but all this stuff. But then we said, well, wait a minute, we're just big bags of water, basically. Because what those series of experiments showed is that water, or especially structured water around an electrode, amplifies weak electromagnetic fields. I mean, we actually showed that. And in fact, Dr. Tiller said, no, that's not impossible. Water can't do that. So come on, Bill, back here to the lab, and well, I'll be darned. He spent 6 months developing a mathematical model of how it did that then. Anyway, I'm sorry for all these sub comments here as I'm thinking it through. So then, but basically that then led to not only are we radiating these magnetic fields, but our physiology is exquisitely tuned to detecting them. So we're able to measure and basically show that there's always this energetic, I'm going to call it energetic, but magnetically mediated, the things we can measure, information flow going on between people, right? And how it's unconsciously affecting our perceptions and biases and these kind of things. So most people aren't aware of it. Some become more consciously aware of it.
Is it almost the idea of like the feeling that you get when you're around somebody? There's a feeling that some people can put their finger on, some people may not be able to, right?
Yeah, well, exactly. So, yeah, and then that led to, a whole other branch of our work on physiological synchronization. And we're still doing a lot of the new studies in that realm. This is a long-winded answer to your question about which then led to, well, okay, so we can see these interactions going on in the local environment, right, when we're together, within each other's fields. But we had enough experiences to know that there's something going past just the local. There's a non-local connection that was occurring. And that's what led to us starting what's called the Global Coherence Initiative. And that's we keep adding new tools to our toolbox to research the more global interconnection aspects. And the first one was and I wish we didn't have to do this ourselves, but we now created a global network of magnetometers around the Earth that are measuring what's called time varying, but the moving aspects of the Earth's magnetic fields. Yeah, which happen to overlap human physiology exactly. I mean, it's kind of amazing once you start measuring it. Anyway, that then led me to another mentor I learned a lot from, and Franz Hallberg, which is a name you may not have heard of. A lot of people haven't, but everybody's heard of circadian rhythms. He's the man who coined the term circadian rhythm. All right, he's unfortunately all these guys have all passed away now, but I'm becoming the old guy. So it was I learned a lot from him as well, and amazing career that Dr. Hallberg had. But it was through him that I learned about what you asked me about. First, he introduced me to that, and so that's Chesovsky's work, who was a Russian astrophysicist who got drafted into World War I. And so he was in the middle of the war, right, and also keeping an eye on solar activity. And what occurred to him, what he was observing is that during higher solar activity, people down here on Earth just tend to get a little more stupid. and aggressive. And so I got him curious. So after the war, he did an exhaustive study of human history. Kind of amazing what these guys did back before we had internets and things, but really impressive work when you really get translated into Russian. So there's enough translated work to his original work. And the graph you're talking about was from 1749. He plotted the number of major human events that occurred every year from 1749 to 1926. That's when he published the work you're talking about. So it's just kind of almost sine wave looking graph with different amplitudes and rhythms. And then the solar cycle right by it, and they're exact overlays. I mean, it's so it showed and he actually predicted to some of his physiological studies that there had to be some unknown forces from the sun that we didn't know about that was affecting human physiology and consciousness and behavior. Of course, again, this is 1920s, right? Nobody knew about X-rays or what's now called the F-107 solar radio flux and ultraviolet. None of this was known at that time. So anyway, sorry for such a long-winded answer on your question.
No, I love it. I very much appreciate that. JP, did you have a question there?
No, I'm just I'm excited to dig into heart rate variability and the vibrations of the heart.
Yeah,
let's do that. So you've been able to explain how there's this connection of frequency changes and magnetic fields that each of us radiates as a human externally. Let's talk about that on the internal level. Let's talk about what is happening inside the body, that heart to brain connection.
Okay. Where do you want to go? I mean,
let's start with...
you guys are experts in the vagus nerve, right? So,
we're aware of it.
Awareness, definitely. So let's dig into that. The autonomic control of the heart from the brain. We have the sympathetic, we've got the parasympathetic.
Autonomic control of the heart from the brain. Well, that's not necessarily true.
Okay. We do know, the SA and AV nodes in the heart are innately there, and the heart does have an innate heartbeat on its own. Autonomic regulation is going to be different.
All right.
So I'd love to hear your perspective.
There's chemical activation of the heart muscle. I mean, that doesn't have to be nervous. It can be,
of course,
direct chemical.
Well, okay. So this is where meeting Dr. Armour, and I forget what year it was. It was pretty early on in the night, somewhere in the later 90s, through some of my other colleagues and mentors. But and are you guys aware of the work in neurocardiology? I assume
some
you
of
would.
it.
Yeah. So anyway, the 1991, Dr. Armour, John Andrew Armour, introduced the nickname of the heart brain as the nickname for the intrinsic cardiac nervous system. And so through him, he kind of took me under his wing and ended up getting invited into all the neurocardiology conferences, and they got interested in our work and that. So it started to make that introduction and what I learned through that world, it started answering a lot of questions that were kind of mysteries. So if we go back, of course, the anatomy of the ANS goes back to the late 1800s, right? Especially in Europe and Vienna and these places, neuroanatomists were mapping all this stuff out. And and then you had William James and, his ideas of the afferents from the autonomic, effect psychology. And that was kind of the dominant perspective until the late 20s, early 30s. We got Cannon coming along and the stress, fight-flight response and, this dumb nervous system that the brain tells the body what to do and all that. So that shifted things until the really 1970s when John and, the Lacey's, John and Beatrice Lacey came along, who actually used to work in Dr. Pribram's lab. The history of that, it's kind of amazing to unravel. Who found that, well, no, wait a minute. The heart has its own particular logic. I don't know if you guys have ever read their work or not, but they were the ones that were showing that the body wasn't, especially the heart, wasn't just bouncing and reacting to the brain, that it was making its own independent decisions. So you would have all the measures of more sympathetic activity. So heart rate's supposed to go up, right? But a lot of times it didn't. It would go down, right? And vice versa, right? So that's kind of started a whole paradigm shift. Took a while because nobody believed him at first, and there was it's actually worth reading all the papers, back and forth papers back then. Anyway, they became very famous and ended up winning all kinds of career awards and introduced they were actually wrong on the mechanism, but what the idea they had was right, was that the afferents from the heart were affecting perception, where it was modulating brain function and somehow knew ahead of time what the brain needed to do next. Right. But what they didn't know about was the intrinsic cardiac nervous system at that time. That came later through the neurocardiology work, who showed that the heart does in fact have that was called the intrinsic cardiac nervous system, or the heart, nicknamed the heart brain. So what I learned from Dr. Armour, we became pretty good friends and a big mentor, was that all the textbooks most of the textbooks still have it wrong, which show all the efferent autonomic functions coming down to the heart, but going to the SA node and the AV node and the cardiac tissues. Completely wrong. All of the efferent neural connections in the autonomic nervous system connect into the intrinsic cardiac nervous system. None of them go directly to the SA node or the cardiac tissues. Right. Then within the heart, you've got about 50,000 sensory neurons. Right. It used to be called, still in some circles, called baroreceptors, baro for pressure. Right. But neurocardiology language are called mechanoreceptive neurons. It's not just pressure. They're sensing, yes, pressure, but rhythm, rate. And it's also kind of important to note here for you guys who understand this, they're most sensitive to increasing their output to rate of change. The bigger the rate of change, the more the output, not just a static kind of, they're a bit nonlinear. So only 20% of the sensory neurons are in the mechanosensitive category. The other 80% are chemosensitive neurons. Right, so they're sensing chemistry, right? Hormones and neurotransmitters, and kind of when you think about it, if you wanted to know what the neurochemistry in the blood was, where would you put that sensory system, right? Right. So those are all inputting into the intrinsic cardiac nervous system, which is then integrating the efferents from the brain, right, and making its own local decisions. And so the heart has to be able to make decisions that's best for the heart. And this makes total sense when you want to step back and think about it. I mean, this one example. I think most people can relate to. We know if you have too much sympathetic drive, you can drive the heart into arrhythmia, right? Sudden cardiac death is just, what kind of well known. Well, if you get really pissed off at someone, or you're over driving, or climbing a hill, right? Sympathetic. Well, if the heart didn't have its own intelligence and its own nervous system to say no, stop, right, and make a shift, we probably wouldn't survive. Follow what I mean? So just basic functional. At a functional level, this is kind of important and makes a lot of sense. It just took us a long time to figure it out.
It almost has its own internal regulation so as not to just take on the neural inputs as the overarching.
Yeah, right. So this explained all of the Lacey's observations many years earlier. Finally, then we've now had the mechanism.
If you do a vagotomy, the heart rate is going to go up. It accelerates rather rapidly, but over about a 15 to 20 minute period of time, it'll settle back down, but it'll still stay at an elevated level compared to where it was when the vagus nerve was still intact. So there is that balance between the two sides.
Oh, of course there is. Right. But I'm talking about just giving an example of an extreme example where if you had just continuous sympathetic drive, you would, because a normal function, that's not, of course, not the case. But
so let's talk about what changes that and how that's measured in HRV, I guess.
Let's talk also about cytokines and how you mentioned several different sort of chemical sensors that exist, but how the immune system is communicating with the heart and the brain through these chemical sensors.
Yeah. Well, you guys are more experts in that than I am. That has been my focus. So I can learn from you on the immune. I mean, I am aware that, at least from my understanding, it is more vagal parasympathetic. That is, I often say this anyway, I hope I got it right, is more interacting with and kind of bidirectionally talking to the immune system, where sympathetic is more, which that I know a little bit more about with the hormonal system.
Well, they both interact with the immune system. What you see with stronger sympathetic activation, especially chronic, is an activation of the immune system into a pro-inflammatory state, whereas with parasympathetic, you get a downregulation of that pro-inflammatory state, or a return to a homeostatic state. There are TNF alpha and IL-1 receptors on the vagal afferents, and you were talking before about efferent signaling, but there's also, it's it resonates with me, and I love saying resonates in this context, but it resonates with me that there's a lot more information going up into the brain than coming back out. So to say
absolutely.
that there's 80% of the information, if not more, is going up into the brainstem. The brain is monitoring what's happened, but where the source information is, what's your source material? It's from the peripheral. And so you're sending information up through 80% of those fibers are after it.
Yeah, exactly. I was going to go there myself. Thank you for saying that, because 80% is the conservative estimate of the vagal fibers that are afferent. Of course, the vagus nerve being the longest nerve in the body. You guys know a lot about this. There are thousands of neural fibers in each of the two vaguses. And,
like hundreds of thousands.
Yeah. Well, at least I know of from Dr. Armour, at least many thousands. I don't know about hundreds of thousands, but I believe you on that.
200,000 on the right side and about 120 on the left.
Okay, well, great. So I've learned something new here, the actual number. I'd love to have the reference for that.
Sure.
I really would. But most estimate 90%. So somewhere between 80 and 90% of the vagal fibers are this way, right, afferent. And the majority of those are coming from the heart and cardiovascular system, right?
On the left
and the
side.
Digestive as well. But yes, there's a different side to side.
Yes. On the right side, sorry. On the right side.
Side is more cardiovascular.
Yeah, so the heart's sending way more information to the brain than the other way around. And this goes back to the Lacey's work, showing that the information in those afferents are go to what we now know every major brain center, including your frontal cortex, right? So that kind of started closing the loop on understanding the Lacey's observations back in the 70s.
At some point, we're going to be able to swing this all the way back around to consciousness. Because
absolutely. I mean, that's
a whole bunch of work that talks about vagus nerve being the root of consciousness itself. But I don't want to go there yet. Let's get
okay. All right. Well, and of course, we got Porges' work and the social engagement system and so on. But, yeah.
Let's talk about some of the emotions, I guess, because the heart is going to take in function of what's happening around, right? And we're going to understand what's happening within the heart. We get these gut feelings, we get these internal sensations of something that's occurring, and that's going to send information up to the brain. Talk a little bit about the perception that the heart itself has, those internal feelings.
Okay. Well, there's two different ways we can go here that are relevant to your question. I mean, if we just keep it standard physiology, right? We got all the afferents coming up. So this is where Prebrum's work. I'll have to talk about him now. And it actually took me a while to really get what he was trying to tell me over a few years. And when I finally got it, it was like, why did it take me so long to understand this? This Prebrum's work, he was one of the pioneers. He was actually one of the first neurosurgeons that ever existed in the world. Kind of grew up knowing nothing about the brain to being world expert on it. And one of his passions, he's a guy who first mapped out the limbic system, and he's a guy who coined the term executive functions for the frontal part of the brain. I mean, this, so we understand who we're talking about here. But one of his passions was trying to understand emotion. And so he was, really probably the world expert in the amygdala and what it did and functions. And so I would always, read a new paper or a book and show it to Carl when he's like, look, I'd get all excited about it. He'd read a page or two and throw it in the trash can a lot of times. And Carl, but this is so cool. And he goes, no, here's where they went wrong. He was a student of mine back in so-and-so years. But anyway, one of the things that would really upset him the most was when people were calling the amygdala the fear center, things like this. He said that is just utter nonsense. So I'm going to see if I can't make a little more complicated story pretty simple, at least from his perspective, and our work certainly suggests he's right, is that what the amygdala does functionally is determine what is familiar and not familiar. Okay.
Familiar,
so you have different parts. Yeah. Well, or happy, not safe, not safe, right? Familiar, not familiar, really what it does. So you've got one part of the amygdala doing that for the internal sensory systems in the body, interoception, right? And another part's doing it for the external sensory systems, what we hear, see, smell, etc. Well, it turns out, back to neurocardiology, the central nucleus of the amygdala is synchronized to the heartbeat. So there's a direct, one of those afferents, goes to the medulla, MTS, then directly to the amygdalas, right? So you can measure, and this has been experimentally measured, that every time the heart beats, a couple of milliseconds later, the cells in the core nucleus of the amygdala are firing with it. So whatever that rhythmic pattern of the heart is going directly to the amygdala. So now this started to explain our observations, earlier observations, that emotions are reflected in the rhythmic pattern of the heart, right? The
This is where
beat
panic
changes the
disorder
pattern.
comes in. This is where
Right.
panic disorder comes in.
Well, right. So anxiety looks different than frustration. I mean, they all have their unique pattern that has individual differences, but it's globally kind of similar, if that makes sense. All right. Now, I'm going to take a sidetrack and help bring me back to where I was going, because it's really, you mentioned panic. So there was God, I'm horrible with past time references, but some years ago now, there was a study in panic disorder where they were also doing 24-hour Holter measurements. And what that study accidentally found was that in about around 50% of the patients with panic disorder, they had undiagnosed sudden onset atrial arrhythmias. And when you treated the arrhythmia, guess what? Panic disorder went away, right? So you have an arrhythmic pattern that's going directly to the amygdala. So it's part of this story so what Pribram was able to show, he actually proved this. Well, I mean, I'm getting ahead of myself now. But basically, the way to think of the amygdala is it's monitoring, let's take on in the internal sensory systems, familiar, not familiar, right? So to do that, you have to have what he called familiar baseline reference pattern to compare the now to, right? So yeah, your baseline, we just call it your baseline around it to make it simpler. So that the amygdala is always comparing the now to the familiar and looking for a match or mismatch. And then you've got the higher cortical stuff monitoring the degree of the mismatch and labeling it. I feel hungry, I feel anxious.
And the amygdala responds differently and will perceive things differently, because the brain is a prediction machine. It's going to make a prediction as to whether or not something's a threat or not a threat based on familiarity. But it changes how well it does that, or how it makes split decisions based on things like cortisol levels. And so, it's a feedback loop.
You're right. You're right. And in Pribram, the way he talks about that, like whether it's cortisol or the different neurochemicals, affect the sensitivity and biasing of this mechanism I'm discovering. Okay, so it's part of the story, but more fundamental is, I think, is the familiar, not familiar. So the heart, in fact, I've got a quote, one of his quotes I use in a lot of presentations I do from Pribram in 1969, where he perfectly describes the heart being the primary source of rhythmic activity in the body that the amygdala is constantly exposed to, is the primary source of establishing the familiar reference pattern. I would often tell a story from my childhood to kind of illustrate this. One of my grandmothers drove us nuts as little kids with her worry and anxiety, just constantly. She grew up, in the Depression era and kids and all this stuff, right? And during the war and so on. And what I now understand, in looking back to her, is that worry had become her familiar baseline. So now the brain wants a match. It's going to do everything it can to create a match, because when you have the match between the familiar and the reference is when we feel comfortable.
This is exactly what we've talked about on multiple podcasts, talked about with respect to many chronic conditions, chronic pain conditions, chronic gastrointestinal discomfort, even depression and anxiety. One of the things we've seen with therapies for treating depression, like vagus nerve stimulation, is that simple things like like asthma or migraine headaches or things like those things are so much quicker. They respond so much faster to the changes, whereas changing how you perceive something as threat or as sad or uncomfortable, those are things where there's been neuroplastic changes, and it biases that section of the brain into a pathway where inbound signals, which are inherently ambiguous, you have to extract the meaning out of them. When the meaning is extracted, if you have a system that's biased in favor of saying, oh, it's a problem, or, oh, I got to worry about that, or, oh, this is risky, you're going to end up with sort of what my grandfather referred to as a free-floating anxiety. That was my grandmother. You and I must have the same grandmother, because my grandmother had a free-floating anxiety. And, I don't know if it was because she, lived through
it's because her baseline, our grandmother's baselines were anxiety as the familiar.
Yeah. Spanish flu, World War I, depression, all that.
Right.
Yep.
So let's continue this. This is an important discussion, I think, because what Pribram proved was that the only way to establish or change the familiar internal baseline reference pattern was to change the afferents on an ongoing basis that caused it to form. Then the heart is the primary the primary source of that biasing mechanism.
Which is why vagus nerve stimulation is so important, because vagus nerve stimulation has the ability to, over a long term, change how the autonomic nervous system responds, which means the afferents change.
Well, ultimately, yes. So a couple important things come out of this once you really understand this, and we're just touching the baby surface of it so far here. First of all, you cannot think yourself into a new baseline, not directly. You've got to change
logic, or like emotion is the driving factor. I imagine.
I would say emotion, yes, but you have to change the afferent input from the heart, but also breathing and also the hormonal biochemistry are also part of this, but they're less than the afferents from the heart being the direct source of the biasing mechanism. So when you're getting into heart coherence, you're doing two things. You are already increasing vagal afferent traffic dramatically because rate of change. But even more importantly, and this was actually really first established by some guys in Germany, forget their name right now, who actually proved that it's the stability of the rhythm is far more important than the amplitude of the rhythm, of the afferent rhythm. Okay, and then they explained the mechanism of how that
brain
works.
is frequency coded; it's not amplitude.
So now you're talking Prebrum's language, right? Because he was actually, you'd love his. You probably need to dig in deeper in his work, but because you're saying the things that he was the father of, right? So as you are able to set in that, let's just say, coherent state often enough, you're now starting to shift the baseline, and this is when it becomes emotionally transformational for people, right? Because without changing the baseline, you're not changing anything long term. And so once you really understand this, it explains why people hate change. Most people, right? Especially unexpected change. It's
the idea of self-sabotage, right? That we go back into patterns that are familiar, even when they are patterns that aren't generally productively helping us.
Exactly. Whether it's internal patterns, that we tend to keep repeating, or relationship patterns, we keep drawing the same relationship over and over and over. It's all the same. So what the other thing, my same grandmother, maybe you have the same story, JP. She was also an awesome baker. So whenever we would come over to grandma's house, fresh, hot chocolate chip cookies, right? Mm-hmm. So my amygdala remembers that. So I can't walk through an airport, and smell the chocolate chip cookies without having that positive relationship. So see, the amygdala is not just bad fear. It's really any familiar, and it could be familiar, really good things as well, right? So it is really underlying our perceptions of safety, of safe, not safe, threat, not threat, but it's all based on this mechanism we're talking about.
But it's also, I think that the key part for me, the key takeaway is that area of your brain is a network that's extracting meaning out of signals.
Yeah, from the heart.
And just to be clear, there's also a tremendous amount of input coming from the intestines and the gut and the digestive tract.
Nowhere near as much as from the heart, JP. I mean, when you look at the afferents, the cardiovascular afferents are huge compared. Okay, now I said there were two answers to your question, so that's just kind of a basic physiological. All right, so I'm going to go a little bit wider on you guys now. Okay, if that's okay.
Yeah, please.
So one of the things we still hear this to this day, but we kept hearing from people who were practicing these heart coherence skills, which is really how do we make that shift from incoherence or dysregulation to regulation, coherence to coherence, whatever words we want to call it, in sync to out of sync to in sync, in the moment in people's lives. It's really what HeartMath's about, is the tools and techniques that allow us to navigate daily challenges and stresses with more, being more centered and easeful and so on. Well, what we kept hearing and still do is that my intuition's on steroids, right? It's dramatically increased. And then usually second thing, and now synchronicities have become a way of life. I can testify to that in my own life as well. So we ended up figuring out, with actually the help of another friend, Dean Radin, he had developed this protocol for, anyway, I need to go into that. But so we published a couple papers called The Electrophysiology of Intuition. And we spent a couple of years doing this and a couple of different protocols. But the first one was you're sitting at a computer and we're wiring, measuring EEG and ECG and the skin conductance and these kind of things. And you push a button, and then in the first protocol it was 6 seconds, and later we went to 20 seconds. But then the computer, after the data has been collected, randomly selects an image that it shows to the person. So there's no way anyone can know what this future image is going to be. And a lot of care goes into making sure that there's no sensory leakage, and it's truly a random process. So it's either an emotionally negative image, that evokes a stress response, snake striking at the screen, or, yucky stuff, about as edgy as you can get it and still show it to a person, an adult. Or it's a nature scene, a bunny rabbit, flower pots, things like that, right? In a way that, long story short, what that study showed was that the heart gets the information first, right? Using heartbeat evoked potentials, right? That neural information sent from the heart to the brain is significantly different. It's highly correlated with the future image before you see the image. Then you get a brain response, then a body response, all in what we call the pre-stimulus before you see the image. So the gut gets the credit, right? But it's really heart, brain, body, where if you're paying attention, it becomes a conscious feeling, right? You need the body change for it to become consciously felt, whether it's the gut, in the gut, or the hair on the back of the neck, or whatever. So the heart was the first, and that's been repeated many times, and even meta-analysis on this. So the way I got that published back then, would have been late 90s, was to say that heart, it appears to be connected to a field of information outside the boundaries of time and space. Right? So I told you I was going to go wider on you here. So in other words, this starts to show that, the great religions and philosophies have been right all along, our language, play with heart, put your heart into it, ask your heart. It's in our language, right? Now, this also kind of came back. Now, the Lacey's actually also found this. They just didn't talk about it, but it's actually in their data that the heart somehow knew ahead of time of what the brain needed to do next. I kind of mentioned that earlier. So this kind of intuitive sense has been in the data all along. They just didn't have the courage, and probably rightfully so, to really emphasize what their data was actually showing.
At the risk of opening a can of worms here, is there a reason why you can't imagine or construct a theory around the idea that what you see is going to travel down your optic nerve into your
thalamus?
Yeah,
and first of the thalamus. Yeah.
Yeah, and which is basically the male body, the central male station of the whole nervous system, and that signal is not yet fully interpreted in the brain, but a portion of that is going to go down into the network along the efferents to the heart or to the gut, because people say they have a gut feeling, and you got millions of neurons in the gut that form the enteric nervous system or the heart nervous system, and that there's an interpretation that takes place there. Meaning is extracted. Heart rate begins to accelerate.
Of course.
You're changing in digestive patterns, change acid levels, etc. That signal comes back up very rapidly along the afferents of the vagus, and frankly, the sympathetics may also be involved, and it goes right into that amygdala, which then drives your emotional response and threat detection. And part of the threat that you're detecting isn't necessarily the external threat. It's the internal response that your heart and your gut has had to it. And the reason why I bring this up is because of the experimental data where they've actually taken mice and exposed them to pictures of cats. And the picture of a cat will cause the heart rate to go up and then the mouse to scurry away. But if you cut the vagus nerve, so there's no possibility for that nervous system response in the peripheral to get back up into the brainstem, the mouse will still run away, still gets that cognitive signal, hey, this is a threat, but it gets it without having the autonomic response.
Well, of course, what I don't disagree with anything you just said, but I think you missed what I was saying earlier. I would just add one thing to that, being you said that, JP, and this is, again, what I learned from Pribram, is that there's a direct neural connection between the amygdala and the thalamus, right? So the language I learned from him is to think of it as the amygdala is eavesdropping on that flow of all sensory information through the thalamus, optic nerves going directly at it first, but all except for smell, all sensory systems go to the thalamus where they're distributed, right? Smell goes directly to the amygdala. So it's monitoring that flow of information, looking for this familiar, not familiar process we were talking about earlier, literally before the information even gets to the optical, the occipital or the higher cortex. So emotion happens first, familiar, not familiar. Everything you said, I would agree with. But what I was talking about in our experiments was all before you see, this is seconds before you see the image. So I'm talking about an intuitive signal that's coming from another perspective in what I was explaining earlier. And that's not to take away from what you said. I would totally agree with everything you said. Once you see an image, in fact, we would see that as well in our own data with the experiment. Once you saw the image, it exactly goes on. You see a huge stress response and you see all the autonomic stuff. So anyway, it's probably too wide for you guys. So we can.
Now I'm just wondering by what mechanism you're suggesting that people would have that premonition.
Yeah, well, good question. I mean, we've defined 3 different types of intuition, and we probably should go somewhere else on this one. I can already see that I'm kind of stretching you guys a little bit on this one.
Oh, good. Okay. I want to ask a question, though, on that. Is there a way that certain people tend to feel a little bit more comfortable with unfamiliar moments?
Sure.
And those feel that like unfamiliar is just something that I'm not capable of doing. Is there an adaptability or resilience piece that comes in there?
Well, of course. I mean, you can think of adventure or as a familiar.
Yes.
Does that make sense?
Curiosity.
I'm kind of one of those people. I mean, I like change in certain ways and would actually, especially when I'm younger, they seek it out. And so that is a type of baseline.
Yeah, I used to describe myself as a risk-friendly individual, not risk-averse. I'm risk-friendly.
I like that. And are there patterns, like childhood patterns or
Absolutely.
or experiences, any specific ones you can outlay as like potential driving factors as to what scuffed the lens through which you see the world?
Well, I would say, remember, go back to the familiar, not familiar process, right? That the amygdalas are really involved in. So a lot of those, and we have many, many baselines. It's not just one. I mean, you gain familiar, not familiar. It's about, like if you think of it, if you go to a new area, a new country or city or something that you're not familiar with, you're a little more vigilant, aren't you, when you're out kind of, right? Until you navigate, say, an area of that area, and then you start to get familiar. This is pretty safe, and I don't have to be so on guard. That's a type of new familiar that's been laid down, right? Or if you're on your first adventure out a certain area, it was pretty edgy, and there were, people. I've actually had this happen with machine guns standing around and stuff like that. You have a different familiar reference now to that area. So I don't know if this is helping put this together for you or not, but.
It is, but I think for me, I'm trying to think on a very productive way, right? So rather than avoid the fear, how do we productive out of curiosity? Teach them how to be coherent. I love it.
I mean, if my answer is going to be heart coherence practices, right, which are the rapid straight line way to repattern or reestablish a new familiar baseline, especially if it's maladapted, like our grandmothers were, right? And childhood absolutely has a major impact on forming those familiarities.
Yeah, there's studies that they can tell whether or not a person's going to be introverted or extroverted within the first month of life, and literally they just put the child in a little car seat and they expose the child to certain lights and certain pictures, and how the child responds, whether the child closes its eyes, turns away, et cetera. They know whether or not that child's going to be an extrovert or introvert, because that's just the bias of the way that formation in the brain was generated.
Well, interesting that you bring that up too, JP, because there's a lot of really neat studies. This was primarily done by, I'm forgetting her name. It'll come to me in a second, in Israel, who has done a lot of work with primary caregivers, usually mothers and young babies, showing an exquisite synchronization between mom's heart rate variability and the baby's. And of course, mom is acting as the primary source of self-regulation in those early months in that context.
They had 9 months to communicate directly with one another. So there's a lot of building that happens that is literally one is attuned to the other.
Well, exactly, but it's that synchronization, and they've shown that synchronization doesn't happen between, I'm going to say mother, but primary caregiver and the baby, the infant. That is forming the self-regulatory networks in the child, and the basis of what becomes the self-regulation circuits later in life. So if that literal, very fine-tuned heart rhythm synchronization between mother and baby doesn't occur in those very early months, then this is what happens. They've been able to show that in later life, that leads to lack of self-regulation and all the issues that we all know that happen from not learning those fundamental skills.
And this explains the basis. This explains the basis of the polyvagal theory, which is on that maternal bond and the experience of maternal voice, mother's voice, the frequencies that mother's voice
feeling of safety,
exactly the driving of that feeling of safety being a major factor in enabling vagus nerve capability.
It also ties back into the whole issue of how the brain is actually constructed by the immune system, and that if the mother's immune system is active in a pro-inflammatory way, it will literally alter how the construction of the brain occurs in the child. Not just the brain, obviously the entire body, all your organs, your susceptibility. 80 years later to neurodegenerative conditions or cardiovascular conditions are set at the time of gestation, and it's a function of how the mother's immune system was functioning at the time. So, this old wives' tale, we've talked about this before, of women who are pregnant need to put their feet up and eat bonbons and not be stressed. That's not false. That is true, because the reason for all the problems that come later in life at some level can be tied back to how you were formed. Were you formed in a way that was susceptible to these things or was protected against these things? And that is a function of how the mother's immune system was functioning during gestation.
As much as I would love to be able to go back in time and help people change what happened in the past, it's obviously not realistic quite yet. We'll get there. But let's talk about some of the practices of creating that coherent state within these practices that people can start to implement so that they can change how they feel day to day.
Yeah, that's a great question, because whatever happened in the past, we do have the power to change.
The effects of it, yes.
Or how we experience it, right? Or how we experience
it. Yeah. I mean, I'm a firm believer that we can change, and that's another story. But I was about to go down, but I'm going to self-regulate and not do it. That's really what HeartMath techniques are about: is how do we self-regulate in the moment, right? In day-to-day challenges. For example, we had the honor of developing the resilience program for the U.S. Navy, in their highest stress. They had a great program conceptually, but what it lacked was the how-to. How do you actually maintain your composure when in the midst of the chaos, right? So, which our early work really helped. So we know that when you're in this, what we now call heart coherent state, right, you're now sending a very different afferent message to the brain that's stable, right, which increases neural synchronization. So you're able to facilitate frontal cortical functions, foresight, right, discrimination of appropriate behavior, better decision-making, discriminations, reaction times, all that's improved. So how do you shift into that coherent state in the midst of chaos or traffic jams or staff meetings where that person who does what they do is doing it again, right? That, the real life context. So there's about 8 core HeartMath techniques that are used in different contexts like that. And one of we actually were the first to, I guess you could say we kind of created the field of heart rhythm, of HRV biofeedback. We're the first to create a device. And we actually did that as a way to facilitate learning those self-regulation skills of how you shift the autonomic state from, you can say, dysregulated to regulated, incoherent to coherent, out of sync to in sync, because it's all literal. It's different language for the same thing in the moment. So using the practice of the real-time heart rhythm feedback, when we feedback, this is where a lot of confusion's out there in the world, by the way, about HRV. Because we're really measuring and feeding back not the amount of variability, but the pattern of the rhythm, which is where coherence shows up. And that is for a lot of people, a serious facilitator of learning, of repatterning that baseline we were talking about, right? Because you're sending the afferents long enough, and now it's the coherent, stable state, which is what we want our baseline to ultimately be, right? So it's a very powerful tool for facilitating those skills of being able to you can use different language, maintain our center when the blank's hitting the fan, or these kind of things, or just making a better decision, or wanting to be able to get into that. We got in those intuition studies I was talking about, we just touched it barely that got into that, but being coherent opens that access to that. I'll just call it heart's intuitive guidance or intuition. We're actually able to show that neurophysiologically, right? That channel's opened up. So in fact, there's, when I bringing up the heart rhythm, the HRV coherence biofeedback, some awesome, I think, new studies have just been coming out in the last couple of years. A lot of them from USC, University of Southern California, by a group down there. Mara Mathers, her group, have now shown that they use one of our devices called the M-Wave Pro, which is a more professional biofeedback device. And these are large studies, she's now shown that just having people be in heart coherence. I think she started 10 minutes a day for the first week, 15 minutes a day the second week, then up to 20 minutes for 4 months. Significantly reduced amyloid beta and tau levels in both young and old people. She's also now shown that same practice measurably increases the neural mass in the frontal cortex, right? Measurably increases the functional connectivity between the frontal cortex and the amygdala, the very self-regulation circuits that we need. Results in increases in resting state HRV, which correlates with reduced mood disturbance and negative emotions. I mean, and the list goes on. And that's just from doing just setting in a coherent state for long enough periods. Because I would say, yes, that's all true, because I mean, you're definitely rewiring the brain, but you're also changing that baseline reference pattern. That kind of practice is enough to really establish that as your new familiar, which the brain then automatically wants to regulate to be familiar. Right. So
describe for me how you measure this coherence in an individual. How do you measure that with? Is it magnetic fields? Is it
HRV?
It's HRV. So basically, anything that elevates HRV is going to have the downstream effects of all the things you just talked about.
Okay. Right. No. And it is true that if you're in, this is where a picture's worth 1,000 words. If you
try to talk about the pattern.
Yeah. So this is where a lot of people are misunderstanding what I've been saying for years. And it comes from, there's a surface level understanding of a lot of researchers, I would say, of HRV. More HRV good, low HRV bad, right? Well, yeah, sort of. And I've seen so many studies get published in the years.
It's context dependent.
Have great results, but they don't know it because it's all about how much HRV. So just for maybe this is probably stuff you're well aware of, but in terms of what HRV is of course the beat to beat, the time intervals varying between each pair of consecutive heartbeats, right? Which creates this file called the interbeat interval file. And there are many, many ways that you can analyze that string of numbers. Right. There's time domain, frequency domain, complexity analysis, nonlinear. I mean, we've dabbled in pretty much a lot of it over the years. But here's the thing: we have the highest amount, or you could translate that to the amplitude if you're just sitting still, the heart rhythm going up and down, whether it's chaotic or coherent, when we're young, and that gets less as we age in almost a linear relationship. And we have one of the most reference papers in the field was one that we published with another one of my mentors, a guy named Don Singer, who's often credited for coining the term HRV. Oh, there you go. Great. I know. Oh, this is a great image because now this is the same person. So the rhythm on the left is what we call an incoherent rhythm. And that's what our rhythm tends to look like if we're feeling impatience or frustration. Anger, it gets way worse, right? More chaotic, which is literally reflecting a desynchronized activity in our higher brain systems, by the way. So if I asked you, I'm not going to do it because it's kind of a trick question, which of those two rhythms has the highest amount of HRV, right? Usually people, about half the audience will guess one, and half the other guess the other. It's a trick question because the amount of variability, the amplitude is identical, in this case, to 2 decimal places. So what's different is the pattern of the rhythm.
Essentially the resilience, the ability to go between sympathetic and parasympathetic.
Well, that's yes, but that's not okay. We just published a paper actually a couple months ago that looked at 1.8 million HRV sessions where people also reported emotional states, and it clearly shows that the emotional state is affecting. The language I used in that paper was the stability of the rhythm. And there's absolutely no question now that the stability of the heart rhythm and that kind of sine wave looking pattern is what maximizes neural synchronization and enhances cognitive functions. The brain has to be able to synchronize its own activity. So I can say a dysregulated or regulated nervous system, and it's completely accurate language, or in sync or out of sync. The point I'm trying to make here is a lot of people got this notion of high HRV good, low HRV bad. Well, that's true if you're looking across the lifespan. It's very slow changing. So if you look, we've done thousands of 24-hour, HRV recordings. In fact, Dr. Donald Singer published back in the 90s the paper that established normative data for what HRV should be for age from age 9 to 99. One of the most referenced papers in the field. So now, that when we talk about how much HRV, that's important in terms of risk assessment, things like that. Because if our HRV is declining faster than the normal age-related decline, that's bad, right? And that's associated with every major disease and a strong predictor of future health problems. But that's very slowly changing, and in fact, it's about every 2 years to even see a significant decrease in the various HRV metrics across the lifespan. Now, that I can say with pretty good confidence that the number one reason that, I'm talking about the amount of HRV now, or you can think of the amplitude as the rhythm, that does start to decrease faster than a normal age-related decline is chronic stress. No question. Yeah, we do analysis for clinics all over the world, mostly functional medicine clinics. Second reason is chronic disease. I mean, it usually something to do with high inflammatory issues. Okay, high inflammation is what's taking out, I think, the nervous system here in this case, or the autonomic system. Now, with that said, what's even more fundamental and important that you can derive from HRV is the pattern, and that's when we're talking about coherence or incoherence, because that's reflecting current state. And so coherent and incoherence is a measure that's independent of how much, right? So you can be an old guy like me. I'm in my 70s now, right? So the amplitude, like the one on the right you see there, that's somebody in probably their 30s, 40s, to have that kind of about a 20, 25 beats per minute average up and down rhythm. So for me in my 70s, it's about 10. But I can be coherent or incoherent. See, so coherence is independent of how much and reflects current state, right? So just making sense. So
absolutely. So it reflects emotional state.
Well, yeah, but it's emotional state is one of the important factors on whether it's coherent or not, but it's not the only.
Emotional, it's physical with respect to your immune system. It's how your mitochondria are functioning with energy. It's this ties in 100% with the paper that the group I'm working with is coming out with shortly, called the autonomic deregulation theory of aging, which basically says that at the fundamental, rock bottom foundation of what aging is, it is a slow deregulation of the autonomic nervous system, which leads to every single aspect of aging across the board.
Yeah. Well, you're right. And it's really the amount of variability correlates in general with what I would just think of as flexibility, physically, but especially mental and emotional flexibility. I don't know if you've ever had to deal with elderly people, but right. I mean, that's the hallmark of aging. Obviously it's the lack of physical flexibility. I'm not nearly as flexible as I was 20 or 30 years ago. But at the same time, you don't have to lose your mental and emotional flexibility through aging. And that's where coherence really makes the difference.
And coherent practice to maintain adaptability.
And hormetic stresses help you maintain that resilience, because your body is maintaining and basically sustaining your resilience to pressures that push you out of homeostasis.
I look at resilience as energy, right? That we have in a, but anyway, that's another whole other topic. We can do a whole other show on that sometime. But
No, this was really great. I'm really thinking about how people in when they're stuck in these challenging states where they lack the adaptability, they lack the flexibility, they lack that resilient capacity to be able to make those changes. What are the practices that they can incorporate? And I my Coherence Plus device is sitting on my bedside table right now. I do love utilizing it, and it's such a great feedback tool. The HeartMath device is so useful for a lot of people in these situations, and even proactively, right? If you're doing well, teach yourself to do even better, right? I think this is what's really cool about these types of practices is it's not just getting you out of a situation where you're in a negative state.
yeah, I don't know why this kind of intuitively being drawn to one of the kind of a major aha for me. This I learned from another one, Dr. Singer, another one of my mentors that got drawn to us early on because of our HRV work and the patterns. He's one of the three fathers of HRV, true fathers of clinical HRV work, that associated it with sudden, higher risk of sudden death and all that. And that is that if you de-innervate the human heart, cut all the sympathetic, parasympathetic connections to the intrinsic cardiac nervous system, the intrinsic heart rate of the human heart is about 100 beats per minute. Okay? So the reason I'm saying this is that anytime heart rate is lower than 100, you have a relative balance between sympathetic and parasympathetic is more vagal or parasympathetic. When it gets up 105, 110, now that relative balance is shifted. That I made a comment earlier before we started this that I think that when I hear people talk about autonomic or parasympathetic or sympathetic dominance, I go, I usually throw that in the trash can. It reflects a lack of deeper understanding to me. Or they talk about autonomic balance without context. That's another thing that I just cannot stomach. It's just wrong. And I say that because in what you want, there is no set point for an ideal autonomic balance from my perspective. It's really, you hinted at this, Dr. Beebe, is the system able to adapt quickly and appropriately to the context at hand? So are we able to shift the relative balance, right, as we need to? I'm climbing the stairs to get up to my office. I want more sympathetic. I want my heart rate to go up and blood pressure. I sit down and relax. I want it to quickly to adjust. And HRV is not very good at reflecting autonomic balance. It's not. This idea of the LF ratio being sympathetic, parasympathetic balance is total nonsense from my perspective. What's more reflective of that relative balance and its adaptability is actually heart rate. Okay. Now, the reason I wanted to share this, as I mentioned, we did many, thousands of 24-hour HRV assessment for patients for clinics all over the world. And it is almost scary how many of these reports come back with high 24-hour heart rates in the 90s. So the temptation is to say that they're sympathetic dominance or they've got a runaway sympathetic nervous system. Actually, no. They actually typically, when you look a little bit deeper, have underperforming sympathetic systems. What's happened is a de-innervated nervous system. So the heart's starting to run at its intrinsic heart rate, right? So what happens more often than a runaway bad guy sympathetic nervous system? I want a healthy sympathetic system, right? I want to be able to,
of course,
do things in the world. But it's really that we haven't developed good brakes. We don't have the vagal self-regulation system, right into Steve Porges' concepts and work, but and Steve, the neurocardiology crowd came up with this long before Steve did, by the way, and Julian Thayer. But
this is the concept of you need to be able to switch quickly and efficiently and without struggle between the state of sympathetic activation for exercise, for competing, for working hard, and
climbing
then
the stairs, right? Walking, talking.
Relax, because the longer you stay in that state, I always say, go out and run 3 miles. It's healthy. Go out and run 30 miles. You're going to hurt yourself. Go out and run 300 miles. You're going to be dead. Okay. You need to be able to get back into that parasympathetic state of recovery and you need to be able to switch back and forth cleanly. I think what you're saying separately from this is that it's far more about the coherence versus the incoherence.
Yeah,
That
it's self-regulatory capacity. Yeah,
yes,
that's what I'm.
the incoherent high heart rate variability is a sign of dysfunction and lack of health, whereas a sign and a sign of both physical and emotional health. But if you are in a coherent state, you're resilient, and it could be the same heart rate variability, but you are healthier.
Yeah, it could be the same amount of variability.
Yeah.
So
coherence.
coherence.
HRV used coherence as the sign of health versus lack of health.
Or regulation versus dysregulation is probably a better way of saying it. If we're able to shift into coherence, that enables our self-regulatory systems. That's really the point. So if I'm getting mad at somebody, right, I can pause, take some hard focused breathing, activate a feeling of appropriate emotion, patience, whatever, breathe that feeling. That shifts me into coherence. So now my physiology is stabilized, right? Which then leads to the biochemical and all the hormonal stuff. You're not flooding your system with cortisol and adrenaline and so on. And anyway,
I have an analogy that I share with virtually every presentation I give or every patient interaction that I have. And it's the idea of we've got the sympathetics being like the accelerator of a car and the parasympathetics being like the brake. And it's not that one is bad and one is good. We need sympathetics. The car is useless without the accelerator. It can't get anywhere. But if without the brakes, it's a danger. And so we want to be able to shift between both, use them appropriately. And you can tell, like, the best drivers, the people that can drive the car, are the ones that are efficient in being able to shift between accelerator and brake as necessary when they're getting up to a stop sign or a red light, or they're able to push the accelerator when green means go and they've got to move. And it's this idea that we want to enable that adaptive capacity, and coherence is the measure of that adaptive capacity. It's not about the HRV number. It's about how capable you are in being able to shift the HRV number.
Yeah, think about it as a driving analogy. Think about it as you can't drive with both feet, because if you're driving with your foot on the gas and on the brake at the same time, you're going to ruin your brakes. You're going to burn out your engine and ruin your brakes. So don't do that to your nervous system.
And you're going to use a lot more energy. Think of your gas mileage. I use that analogy a lot.
So in the long run, you want to be able to switch, you want to really be able to shut down that sympathetic, get into the parasympathetic, shut down the parasympathetic, get fully into the sympathetic, but swiftly, easily. I always talk about my dog, the dog that lies on the cold tile most of the day looking like a rug. And then when the UPS guy shows up, he's up and barking and huffing and puffing, and yet 30 seconds later can be back catatonic on the ground. That ability to switch back and forth is enviable.
Yeah, and that's really what I'm talking about is more important than this concept of some static balance. It's the ability to shift relative balance. Because it's this mistake I see a lot of people making in terms of HRV. Well, there's a bunch actually, but one is they never actually look at the HRV. They just look at these numbers, which are they don't have an intuitive sense of what they actually reflect and mean. I was going to go with that statement. But anyway.
Is there a method that people can use to get that coherence versus incoherence measurement, the level of coherence versus incoherence?
Oh, yeah. I mean, we have a whole series of apps, and technologies that make it very inexpensive. In fact, even free for people. We've now developed so you can use the phone on your camera. The camera on your phone is the sensor for your pulse. Not as good as a real sensor, but it works good enough for introductions. So
great trend analysis.
So you can not only measure individual coherence, one of our apps, you can actually measure collective coherence. So we use this in group training.
What that app is. It's a good one. Tell the audience what that app is.
Well, I would recommend people start with what's just called the HeartMath app, right? Mm-hmm. Which you can get and that you can try the phone's camera as an introductory. But I recommend that one for people just first introduction, because it has a lot of introductory stuff about what is HRV and coherence and what how to shift and a lot of the techniques. Or some of the other apps are more advanced, consider that are more recommended by doctors and healthcare professionals who've done some training with people, inner balance. But there's also the Global Coherence app, which is more the collective group level coherence. We didn't get into all that, but we've done a lot of work in more recent years on heart rhythm synchronization between individuals within groups, and how that is really the ground state for pro-social behaviors, better group performance, team performance, these kind of things.
I love that. I think connection is a really big missing piece. People are generally disconnected. They're not able to be in this state. And we know loneliness and the feeling of not being with others or in a group of alignment is a major factor in all-cause mortality, probably the number one factor of all-cause mortality. So creating connection, even through an app, will help to facilitate this idea of enabling that healing response that the parasympathetics provide, but also just building out that global coherence piece that we're all connected. We're all in some way part of a bigger thing than just us.
Well, that gets into our work under the rubric of the Global Coherence Initiative. Like you just said, I've said myself and had my friends say, well, on some level, we're all connected, right?
Yeah,
on some level, some way. Well, what we're doing there is really putting science to that.
Exactly.
And showing that from a pretty rigorous research perspective, how we're interconnected, not completely. There's multiple levels and layers to that.
Well, we have to have you back on to talk about global coherence and get into that consciousness discussion that we were talking about, where the vagus nerve might be the root or the origination of consciousness itself, because it's self-monitoring of the system. So it seems like a whole separate episode for us.
Yeah, it could very well be. Yeah.
Absolutely. I think this has been absolutely fascinating for anybody who was listening to this. I think it helps to dispel the myth of just HRV simply being the end all be all, that we really need to understand that it's the adaptability piece, that coherence piece that is driving our capabilities.
Yeah. I mean, HRV, I'll often say it's really simple. Be changing heart rate, or you can spend an entire career trying to understand it.
Exactly.
It has that. It really does have that kind of breadth. And when you always have to, I think that one of the bigger mistakes that's made, there's a lot, but is not taking context into consideration when they're talking about HRV.
Context is huge.
Context matters when we're talking about it. And
absolutely. I have so many people come to me and say, hey, my HRV is 22 and 12. And I'm like,
me too.
We don't need to worry about that. We need to worry about how do we slowly work to increase that, but also how do we ensure that it's context dependent and what's happening in your life that's causing those things.
Well, exactly. When people throw out these numbers, I mean, again, context matters because the length of the recording matters. There's so many mistakes that get made. People try and compare like normative data. Should it be for my age, right? Well, we have lots of that data for many different measures, but you have to, when you're comparing to a normative database, the data has to be collected in exactly the same way as the data for the normative base was, and it has to be exactly the same time length. These things matter.
Yeah, this makes a ton of sense. And context of just even measurement you're mentioning, but I think all of those pieces really matter in helping to understand that HRV number is not the end all be all. And yes, we have these devices that are great, but they're trend level and they're just great for understanding currently where you stand and utilizing that information to create change in your behavior.
Exactly. That's what I was just going to say, because there's a lot of things out there that measure. Right. Or a ring does it, RMSSD in 5 minutes seconds through the night. That's a great thing, but people don't understand that. Or you've got Whoop and my Apple Watch all measuring HRV and reflecting different numbers. That's all measurement. Fine if you really understand it. But more importantly, let's use HRV as a training tool to really grow our capacity to self-regulate, both physically and mentally and emotionally.
I don't think I could have said it better myself. This has been absolutely wonderful and fascinating, and I think really insightful for a lot of people that are trying to understand what their HRV means, what HRV truly is, and to understand that coherence is that next level to understand whether you have that adaptive capacity within the autonomics, and that's really ultimately what is going to create positive change. JP, any final thoughts there?
No, I'm looking forward to having the next conversation when we get to talk about the next level.
Wonderful. Well, Dr. McCraty, this has been great.
Well, fun conversation, guys.
Yeah, thanks so much for joining us. And if you got to this point in the conversation, share this episode with one person who you think could utilize this information. Somebody who's got that Oura ring and they're stuck with that number and it's driving them crazy, or somebody who is utilizing HRV maybe in not the most beneficial way. So share this with one person who you think could utilize this information to upgrade their health, and we'll catch you all on the next one.